Alright, you guys, these are the double and half angle identities for pre-calc, as you can read for yourself there. Not trying to be Captain Obvious here, but there you go. Alright. When you get ones like this, it's a choice of which formula you want to use. These all will produce the exact same answer. So if you want the cosine of 2 theta, you use this one, or this one, or this one. You don't do all three, because they're going to give you the same answers. Same thing over here. So if you want the tangent of theta over 2, you either do this formula or you do that one, but you don't do both. And I'll explain the plus and minus when we go through these. It's not both of them. You have to choose. There's a choice that you have to make. It's either the positive or the negative, but not both of them. And I'll explain how to find that as we go. Alright, the first thing you guys need to do is do the Pythagorean theorem. You find this is 17. Then when you look at this, it's saying if you were to double the size of that angle, that's obviously going to change the length of these sides. And if you did double that angle, what would the sine of that angle be? Well, here goes. It's 2 times the sine of this original angle, 8/17, times the cosine, which would be 15/17. 2 times 8 times 15 is 240, I believe. And then 17 squared, I forgot already, 17 squared, 289. Okay? And you're done. That would be your answer. Okay? It's not going to reduce because the numbers on top have nothing in common with 17 squared, so it's not going to go anywhere. If you wanted the cosine of twice that angle, you have a choice which one to use. Okay, let's do the first one. Cosine would be 15/17. So you got 15/17 squared minus sine, which would be 8/17. Okay? Slap it in your calculator and see what you get. So let's see, 15 divided by 17 squared minus 8 divided by 17 squared gives me 161 over 289. Okay? If I did it for this one, I'm going to get exactly the same answer. It's going to be twice 15 over 17 squared minus 1. We'll type it in because I'm going to feel better knowing that we got it right. So that would be 15 divided by 17 squared minus 1. Did some funky decimal, and it's exactly the same. Okay? Or you could use it this one. And go 1 minus 2. Sine would be 8/15 squared, and you'll get exactly the same answer. So it doesn't matter which one you use. To get the tangent of twice that angle, well, you just set it up. 2, the tangent of that angle would be 8/15 over 1 minus, the hardest part's going to be typing this in the calculator. So then you're going to get 8/15 squared. So the hardest thing is going to be typing it in. So 16/15 is the top. Is going to be divided by this thing on the bottom. Okay, so if you want, you guys could think of it as you got to double nest this thing, so you're going to have to stick a parenthesis around that when you hit divide. Okay, not multiply by the reciprocal, you're just going to type it in. 16/15 is divided by, put a parenthesis around it, 1 minus 8 divided by 15 squared, close the paren, you get some weird decimal, and looks like 240 over 61. 161. Whew. So looks like, I'll write it up here, 240 divided by 161. Okay. If you wanted to cut this angle in half, what would it be? So you're going to cut it in half. All right. Well, you're not going to change anything there. It's just sine of theta over 2. You're not filling anything in for theta. I'll explain the plus and a minus in a minute. 1 minus cosine of that angle. And remember, you did the Pythagorean theorem, that's 17. So that would be 15/17 all over 2. And now you have to simplify it, and I'll explain this in a minute. So that would be 17/17 minus 15/17 all over 2. So that becomes, and I realize it's a mess, square root of 2/17. My square root's not very big. Let me erase that. It's a big old hunkin' square root. So that would be 2/17 over 2. And that's the main fraction bar right there. You're dividing by 2 or multiplying by a half. So that would become square root of 1/17, which is square root of 1 over the square root of 17. So it would be the square root of 17 over 17. Okay? Alright, so that would be your answer for this one. Now, plus and minus. Sine, think of it on the unit circle, is your y value. This plus or minus is generated by the sine of your y, or dy, at theta over 2, not theta. Now, here, this isn't going to make a whole lot of sense. When we start working with actual angles, it'll be able to interpret that a little better for you. But suffice it to say, aren't all of your angles in a triangle going to be between 0 and 90 degrees? So think of it on the unit circle. Between 0 and 90, what is the sine of your y value? They're all positive. So this is strictly going to be the positive square root of 17 over 17. All right? When we start using actual angles in here, it'll make more sense. But for right now, when you're using a triangle, all your angles are between 0 and 90. So the sine of your y value is based on theta over 2. Excuse me, not theta. Okay, and we'll talk more about that as we go. All right. Cosine. Boy, it's the same pattern. Okay. Wait a minute. Did I just go and do that? I'm a silly bunny. I can't believe I did that. I just found... Oh, that was right. Here I was all upset. Oh my goodness. Okay. Never mind. It's just this that's different. I'll stop explaining and I'll just move on. Okay, cosine of theta over 2 equals plus or minus. So 1 plus the cosine of the angle, which just like we did in the last one is 15/17 over 2. So that would be 17/17 plus 15/17. I believe it's going to be 32/17 all over 2, and it's all in a square root. We haven't decided the plus or minus yet, but we'll get there. So it's dividing by 2, multiplying by half, so that's going to be the square root of 16/17. Break the square root of 16 over square root of 17, so that's 4 over the square root of 17, so that's 4 square roots of 17 over 17. Now we got to decide the plus and the minus, but the same deal goes. This is cosine. This plus or minus is based on the sine of the x at theta over 2. All your angles are between 0 and 90. All of your x values are going to be positive in this quadrant. So once again, we're just going to choose the positive value of it, okay? Not the negative. Tangent, you're going to use either one of these. I'm just going to use this first one. So tangent of theta over 2 is 1 minus cosine theta, which was 15/17, over sine, which would be 8/17. Okay. This is going to be 17/17 minus 15/17 is 2/17 over 8/17. You're dividing by this, so multiply by its reciprocal. 17s cancel, and you get 2 over 8, which is a quarter. Okay? No plus or minus to choose from. All right, here's where it's going to start making a teensy bit more sense when you're using actual angles. This is the half angle. This is worth 15 degrees. Okay? So it's worth 15 degrees. when you set up this pattern, it's really sine of 30 over 2 is the same as, this is the angle. Here, let me back up and rewrite this point. Okay, the pattern goes sine of theta over 2 is equal to plus or minus square root 1 minus cosine of theta over 2. Now, the thing that you need to realize is this theta here is the same as that theta there. Okay? Notice these are two different numbers, you guys. This is 15, this is 30. The number that you're going to use in this pattern is not 15, it's 30. Because it's theta over 2 that I'm using. Okay? Hold on. Alright. Here we are, back again. Okay. So, this just takes a little bit of getting used to, in that it's the half angle that you're going to fill in, which, here, let me just do it, okay? 15 degrees is not an angle that you know on the unit circle. I'd like to know what it is based off of information I know on the unit circle. So, if I look at that, and if I double it, this angle I do know, and this angle is what I'm going to fill in there. So it's going to be equal to, now it's not both of these, I'm going to write them both just so they're there and I know I have to go back and change it. So it's only one of them. 1 minus the cosine, and I'm using 30. I'm not using 15 because 15 is not an angle that I know off the unit circle. It's not going to do me any good to fill 15 into this. Okay? So it wouldn't be any value in doing this half angle identity because it's not 15 is not an angle you know. You want to base it off of information you do know. And you do know about 30. So you're going to use this. Cosine of 30. So once again, you guys got to know the unit circle. Cosine of 30 is going to be square root of 3 over 2. So I've got the square root 1 minus square root of 3 over 2 over 2. I need a common denominator. It's going to be 2. So this is, and I know I haven't done anything with the plus or minus, 2 minus the square root of 3 over 2 over 2. And this is all inside that root. You're dividing by 2, so it's the same as multiplying by a half. So that's the square root of 2 minus the square root of 3 over 4. Now I'm going to split the square root into two different roots. And yes, that square root is inside this other root. I'm not going to be able to deal with that. It's going to have to stay there. Minus the square root of 3 all over the square root of 4. It's supposed to be a 4. 2 minus the, oh my goodness, this is awful. Square root of 2 minus the square root of 3 all over 2. Now I have to go back and choose the plus and minus. Sine is the y value. The sine of the y at 15 degrees. Now earlier I said at theta over 2, and I'm still standing by that. This is theta over 2. It's 15 degrees. Theta is 30. Okay? Because that's what you filled in here. Okay? It's not going to make any difference whether I'm using 15 or 30 for this small of an angle, but it will for larger angles. And we'll talk more about that as we go. Okay? So it's the positive, because the sine of the y at 15 degrees is positive. So you choose positive. Okay? Cosine of 22.5 is the same as cosine of 45 over 2. So then you use the cosine identity. Again, we have to choose a plus and a minus. Square root 1 minus the cosine of 45 over 2. So that's plus or minus, and I get there. I'm just leaving them off right now because we need to focus on this other stuff. 1 minus square root of 2 over 2 over 2. Get a common denominator. So that's 2 minus the square root of 2 over 2 over 2. You're dividing by 2. You're dividing by 2. So multiply by a half. So that becomes 2 minus the square root of 2 over 4. No, you could not have canceled here. It's still in the square root. Split the square root, 2 minus the square root of 2 all over the square root of 4, which is square root of 2 minus the square root of 2 all over 2. And once again, the sign of the x at 22.5 degrees is positive. So I choose the positive version. No, you don't need to write it because it's positive. If it was negative, you need to write it. Okay. Here's when you're going to choose the plus and minus based on this sign. Okay, this sign. Okay. Here goes. So 157.5 is not a unit circle angle, I know. But if I doubled it, so in other words, 157.5 times 2 over 2 is 315 over 2. Okay? This is a unit circle angle that you know. 315 degrees is right there. That coordinate, square root of 2 over 2, negative square root of 2 over 2. All right? I'd like to know what the sine of 157.5 is. All right? 157.5 is hanging out, somewhere about there. I'd like to know what the y value is at that coordinate. But I'm going to base it off of this one, using the property that says sine of theta over 2 is plus or minus 1 minus the cosine theta over 2. Okay? Did I use the wrong one in the last? Let me just look back. Snap. I did. This is a plus. This is a plus. This is a plus, 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 plus. Sorry about that, guys. I used the wrong one. I guess that's a lesson to me that I should write this thing down first before I do it. Theta over 2 is plus or minus 1 plus the square, cosine. Good night. I think I made more mistakes in this one than I ever have. Okay, it's a plus. Okay, I used a minus. I apologize. So it didn't affect anything other than changing those to plus. Sorry about that. Okay, go back to this. I'm going to find the y value at 157.5 based on this information sitting at 315 degrees. So sine of 315 over 2 is the same as plus or minus 1 minus the cosine of 315 over 2. Cosine is going to be your x value, so it's plus or minus 1 minus square root of 2 over 2 over 2. That's this 2 that's here, over 2. Get a common denominator, and this thing's going to become plus and minus square root 2 minus the square root of 2 over 2 over 2. And that's all inside this root. Okay, that 2 down there is still inside it. Okay, if I clean that up and make it look a little bit more presentable. Okay, it's all inside the root. You're dividing by 2, so multiply by half, and you get plus or minus 2 minus square root of 2 over 4. Again, no, you could not have reduced this. Split the square root into 2 pieces. 2 minus the square root of 2 all over the square root of 4. So then that's plus or minus square root 2 minus the square root of 2 all over 2. Now I have to decide sine. Sine is your y value, and the sine of the y at 157.5 degrees is positive. So I don't use the negative, I use the positive. Okay? If you had chosen to look at 315 degrees, you would have said the sine on the y value at 315 is negative, and you would have put the negative on there. But that's not where you look. You look at the sine of the y at theta over 2, which is 157.5. Okay? So you choose the positive. I know that's can be confusing at first, but it's based on this angle, not this angle. Okay, I think that's the last slide, is it? Yep, there you go.